This is lesson 5-4, writing function rules. You can write a rule for a function by analyzing a table of values. Look for a pattern relating the independent or x variable with the dependent or y variable. Okay, let's write a function for each rule of the table here. Let's look at this table. The easiest way to write a function rule is to look at a table and see if you can find a relationship between the x and the f of x or the x and the y. If I look at this, if I look and say from 2 to 8 here, excuse me about that, from 2 to 8, they either add 6 or they multiply by 4. It has to stay consistent from one thing to another. So that's why I'm going to put both of them down there for now until I can figure out what it is. From 4 to 10, I'm either going to add 6, but there's nothing really I can multiply by. 6 to 12, I'm going to add 6. And 8 to 14, I'm going to add 6 again. If you're going to add something, that simply is exactly what your rule is. I look at this and I go, gee, every single time I'm just going to add 6. To get f of x, I add 6 to whatever my x value is. Therefore, my function rule would be f of x equals my x value plus 6. You need to write it in f of x value form only because this is written in f of x. If it was written in y equals, you could write y equals, but it's written in f of x equals. That was a fairly simple one. Let's take a look at one that's not quite so simple. If I look at the second problem here, when x is 1, y is 2. When x is 2, y is 5. When x is 3, y is 10. And when x is 4, y is 17. When I look at this, I'm like, this doesn't seem to be doing much for me. Because I'm looking at it, and let's see here. If you look at this rule, we can say, okay, from 1 to 2, you could add 1. From 2 to 5, you add 3. From 3 to 10, you add 7. This is not doing much for me, is it? All right. Gee, I'm not doing much here. So maybe we need to take a look at something and look at it a little bit differently. Okay? When you notice that you can't go straight from the x to the y or the x to the f of x, like here to here to here to here, like always adding 6 or always adding 5 or always subtracting 3, the next best thing to do would be to take every number and multiply it by something. Take all your x values here and multiply them by something. So I'm going to take my x values and I'm going to multiply them by 2. So now my x value here is going to be 2, this is going to be 4, this is going to be 6, this is going to be 8. Now let's see if we can do anything here. From 2 to 2 stays the same. 4 to 5 adds 1, 6 to 10 adds 4, 8 to 17 adds 9. Still doesn't do anything for me. Okay? So I'm looking at this going, I'm having a really hard time with this. What do I do, Mrs. Schuline? I'm stuck. This is where you need to start looking at it from a different standpoint. You might look at it and just stare at it for a minute, ponder it, look at it a little bit. I'm looking at this going, I see a pattern right here with these numbers right here. I'm looking at these numbers and I'm saying, this is 2, which I'm going to skip for a moment, but 5 is 4 plus 1, and 10 is 9 plus 1, and 17 is 16 plus 1. Let's go back to 2, that's 1 plus 1, and you might say, that doesn't make any sense, Mrs. Schuline. But if you look at it for a second, this is 1 squared, this is 2 squared, 9 is 3 squared, and 16 is 4 squared. So if I take my x value and I square it and I add 1 to it, I end up with my y value, because 1 squared plus 1 becomes 2. 2 squared plus 1 is 5. 3 squared plus 1 is 10. 4 squared plus 1 is 17. So I take my x value and leave this part right here. That was not very helpful. I take my x value and I square it, so y will equal this x squared plus 1. I just look at your values now and then and just try to see if you can find a pattern. Let's look at this third table down here. Lost the bottom part of my table. I'll have to draw it back in. There we go. And look at this. From 1 to negative 1, we will subtract 2. 4 multiplied by -1. From 2 to 0, we subtract 2. From 3 to 1, we subtract 2. From 4 to 2, we subtract 2. So this one's another easy one. My f of x value is going to be my x value subtracted by 2. And that's the function rules. The function rules are not all that difficult. You just have to look at them, see if you can figure out a pattern, and see what happens from there. Now, you also have to be able to write function rules from word phrases and statements. The journalism class makes $25 per page of advertising in a year. If the class sells P pages of advertising, how much money will it earn? We're going to write a function rule to describe the relationship, and then once we've done that, we're going to figure out how much money the class makes if it sold 6 pages. All right, so let's see, it says, if the class sells P pages of advertising, how much money will it earn? So our function rule says the amount of money we're going to make is $25 for each page of advertising that we sell. So the pages, the number of pages, determines how much money we're going to make. So our independent variable is going to be the number of pages. And our dependent variable is going to be the money we make. And it's always good to identify your independent and dependent variables, because if you can identify your independent and dependent variables, it's much easier to write your function rules. Okay, so since my dependent variable is my money, okay, so we're going to write a function rule to describe how much money we earn based upon the number of pages we get. So my function rule, I'm going to make f of p, so it's going to be the function of my pages, how many pages I sell, is going to be 25 times the number of pages, because it's $25 per page for advertising. So if I sold 6 pages, and I'm not going to find f of p now, I'm going to find f of 6, because I want to know what it is if I sell 6 pages, which is going to be 25 times 6. And 25 times 6 is $150. So you will make $150 if you sell 6 pages of advertising. Let's look at one more. The choir spent $100 producing audio tapes of its last performance, and will sell tapes for $5.50 each. Write a rule to describe the choir's profit as a function of the number of tapes it sold. Okay? So the profit is going to be the number of tapes sold at $5.50 each. But we had to spend $100 to buy all the tapes and to actually produce all the tapes. So you have to keep that in mind. So our profit is our dependent variable, and the number of tapes is our independent variable. Because the more tapes we sell, the more profit we will make. So our profit is determined by the tapes that we sell, and we get $5.50 per each tape, but we had to spend $100 to begin with, so we have to subtract that $100 out because that's not part of our profit. Until we make $100, we're not really making any profit whatsoever. Okay, so this is writing function rules, not a very complicated concept.